Hello and welcome. I'm Vignesh Swaminathan from the Prisma Access TME team, as Sana introduced me. Thank you so much for having me here. Today's topic is ZTNA connector, and we are going to talk about the latest and greatest features which were introduced with the latest ZTNA connector release. But before I get into the topic, I wanted to quickly touch upon what ZTNA connector is. So uh, let me start off by talking about what you will be seeing in the presentation. So let's talk about the session agenda. First, we will be talking about ZTNA connector introductions, a little bit about what the product is. We will also get into the architecture. We'll talk about what are the different on-ramp, off-ramp services, and how we give access to the private apps sitting in your data center or cloud through the ZTNA connector. Similarly, we'll be talking about the ZTNA connector capabilities, which will be the recent enhancements. And we will also be showing you some demos on those capabilities for your understanding. And finally, if time permits, I also wanted to touch upon the troubleshooting aspects of ZTNA connector so that it's easy for you to navigate through the Strata Cloud Manager dashboard and easily troubleshoot any ZTNA connector related issues. But moving forward, let's talk about the different customer challenges with the distributed network. With thousands of virtual private cloud, creating and managing that many tunnels, whether it is IPsec, GRE, is a challenge. And customers have to figure out what is the nearest Prisma Access compute location, which is not straightforward to do from public clouds. And multi-cloud connectivity is a major challenge for customers. The next customer challenge is the network complexity, right? So to get that multi-gigabit connectivity, customers have to establish multiple tunnels and manage different routing protocols like static routing, BGP, things like ECMP for distribution of that traffic, etc. And doing this across multiple locations, we can imagine how much overhead that will add. Finally, when we look at scenarios where different companies are acquiring other companies or merging with other companies, which is quite common with large enterprises, the current solutions cannot natively handle access to private apps in overlapped networks. And that is where ZTNA connector comes in. So just to give you an idea, ZTNA connector is a VM which is deployed in your data center or your cloud-based environments like AWS, Azure, GCP, and now we have also added OCI in the mix, which resides near your private applications and connects to the Prisma Access backend so that your Global Protect user, your Prisma Access agent user, or any remote network which basically has a branch device connecting into your Prisma Access, or any enterprise browser like Prisma Access browser connecting into your Prisma Access infrastructure can connect to the private apps easily and securely. So using ZTNA connector, whenever you need Prisma Access to connect to private apps without manually configuring IPsec tunnels, the ZTNA connector comes into play. It basically brings in so many different benefits, including enhanced simplicity, scalability, and flexibility. It automatically connects to the closest Prisma Access location, guaranteeing the best possible latency. Prisma Access compute location automatically scales up to more than 6 Gbps of throughput, which is pretty good when it comes to a customer environment. It fully automates the secure tunnel management and routing protocols for private applications. So the customer does not have to configure any of the tunnels, any of the IPsec configurations, or any of the routing protocol configurations like BGP, etc. Applications in an overlapped networks are fully supported. So for example, if a large enterprise acquires or does a mergers and acquisition with another company, overlap networks coming from the second company is fully supported with ZTNA connectors. So ZTNA connector can be used to access those private apps sitting behind those overlapped networks. It supports both physical data centers and public-private cloud environments. As I mentioned, we have a plethora of deployment options. We have ESXi-based deployments, KVM-based deployments, Hyper-V-based deployments when it comes to physical data center. And when it comes to public-private cloud environments, we have AWS, Azure, GCP, and now OCI, which has been added to the mix. And we also offer secure access to cloud native and traditional applications with ZTNA 2.0, which is compliant. We have best-in-class threat protection and data leak prevention. We have proprietary constructs like app ID, user ID based security policies, device ID based security policies, and ZTNA connector adheres to all these different security based capabilities Prisma Access offers. And as mentioned, automatic discovery of private applications, we have plethora of options to do that as well. We have things like wildcard-based application discovery. We have things like CIE with Okta integration, CIE with Microsoft Entra ID integration, which basically makes it very easy for discovering the private applications. And we also have something called as AWS Auto App Discovery, which we have collaborated with AWS to give that to customers, where private applications sitting behind an AWS account can be easily discovered and used for private app access. We also suggest security policies for those applications. That is something Prisma Access does. We have a lot of automation which has come up. And from a ZTNA connector standpoint, we have wildcard-based security policies which we have introduced. And that basically helps in applying security policies to any FQDN falling under a particular wildcard. And the FQDNs have to adhere to the security policies. So those are some of the quick security-based enhancements we have made with ZTNA connector. Finally, there's no exposure to internal IPs. So we follow a strict Anycast architecture, and we do a lot of masking, which basically protects the internal IPs. And that's another layer of additional security we offer. And all connections to Prisma Access are initiated from the ZTNA connector. So that's another thing which is a huge benefit from a ZTNA connector standpoint. Now, moving forward, let's talk about the architecture. As mentioned before, we have the Prisma Access infrastructure, the cloud, and we have automatic application discovery with our cloud identity engine, which integrates with things, services like Okta, Entra ID, etc. And similarly, we have an on-ramp security processing node, which connects to your users. So if you see today, we support Global Protect, Prisma Access Agent users like laptops or mobile phones, which have these agents running, and they connect to our security processing nodes behind the scene. Similarly, we have remote networks like branch gateways, SD-WAN devices, which connect to our remote network security processing nodes. And now we have also introduced an enterprise browser, which can be used to connect to your Prisma Access by using explicit proxy-based security processing nodes. And if you see on the off-ramp side, we have specific entities which are called corporate access nodes, and those give you connectivity to your private applications by connecting to either the ZTNA connector VM, or if you're using a service connection, it connects to a branch device at your data center or a data center device, head-end device, forming these IPsec tunnels and giving you access to private applications. But if you take a look on the right-hand side at the data center or public cloud, this could be anything. You can see that ZTNA connector uses an IPsec tunnel, automated IPsec tunnel-based connectivity to your private applications. It's a one-click VM deployment on any cloud or on-prem data centers. It's very easy to deploy. We have automatic DNAT and SNAT configurations for overlapped IPs, which is done on the ZTNA connector to reach the private applications. And we can onboard the applications based on an FQDN or a wildcard based entry or an IP subnet based entry. And as I mentioned, the applications can be discovered automatically using multiple capabilities mentioned before. So one more important thing here is that usually once the ZTNA connector VM is deployed, you go into the Strata Cloud Manager UI and you start configuring the connector group first. So these connector groups are logical groups which handle multiple ZTNA connectors. So for each connector group, you can have up to 4 ZTNA connectors, and that is configured on the Strata Cloud Manager dashboard. And once you configure the connector group, you configure the connectors, and then you configure the application targets in the UI. And once that is done, the ZTNA connector, once it is up and running, tries to contact the Prisma Access backend, and using the public IP, the Prisma Access is able to automatically determine the location of the ZTNA connector and updates the location and forms the IPsec tunnel, which starts the whole process of connection to the private application. So that was it from a ZTNA connector architecture standpoint. Now let me move on to the use cases. So these are some of the different use cases we have. As mentioned, access to private apps in overlapped networks. So if your existing organization has acquired another organization and they have the same overlapping IP space, you can use ZTNA connector to connect to those private apps with the overlapped network scenario. We will be using FQDN-based app targets and wildcard-based app targets to do that, and we can support these overlapped networks through the ZTNA connector. Similarly, when it comes to data center to cloud migration, with the ZTNA connector simplicity, it's very easy to migrate your data center applications to cloud-based infrastructure. So that is supported by ZTNA connector because of the automation it provides when it comes to the discovery of applications, the forming of IPsec tunnels, and the configuration of routing, which is automated. So that makes it much easier to transition from a data center to cloud. Now, the next use case is applications in partner networks. Sometimes you need to identify and access applications in partner network, and ZTNA connector can do that. If you have overlapped subnets in partner networks, a ZTNA connector definitely helps you take care of that as well. And we also have Prisma Access browser-based integration with ZTNA connector, which lets you handle private apps in partner networks. If you want unmanaged way of connecting to your private apps, we can do that too. We have something called as privileged remote access, which gives you access to SSH based private applications, RDP-based private applications, VNC-based private applications. So all that is introduced with ZTNA connector. And as I said, these are simple scenarios where you can use a Global Protect client as a mobile user, and you can access private applications. You can use a remote network where you have a branch device connecting into your Prisma Access, and you have some remote network devices which are using that branch device to connect to Prisma Access. They can access the private applications behind ZTNA connector. The other important use case, as I was mentioning before, is Prisma Access Browser, where you can use Prisma Access Browser to connect to your explicit proxy security processing node. You just have to enable explicit proxy on Prisma Access, and that gives you access to ZTNA connector-based private apps. And you can use the Prisma Access Browser to secure your browser and get those browsers security capabilities, which will additionally enhance security for accessing those private apps. Now, moving forward, ZTNA connector definitely supports multiple scenarios, and one of them is where a mobile user or remote network can access applications sitting in multiple locations. So if you have the same application deployed in US East, or you have the same application deployed in US West, you just have to deploy 2 ZTNA connectors in the data center, and you should be able to access those applications through your mobile user or remote network user. Moving forward, again, just for your understanding, we also have a scenario where you can have multiple ZTTs and multiple ZTNA connectors serving the same location. So just to give you an idea, as I mentioned, 4 ZTNA connectors can be in one ZTNA connector group, and those connect to the ZTNA tunnel terminators, which are spun up automatically once the ZTNA connectors come up. And you can have up to 4 ZTNA tunnel terminators in a US region, which supports a different number of applications behind those ZTNA connectors. So you can have multiple connectors serving the same location as well with multiple applications. Now, moving forward, just wanted to talk to you about the ZTNA tunnel terminator spin-up process per compute location. All connectors are connected to all ZTTs in a region as shown before. So when one ZTNA connector is deployed in a particular region, let's take an example of, let's say, US region, one ZTT will automatically spin up a backend. When you spin up the second ZTNA connector, the second ZTT automatically spins up backend, and there is a connectivity mesh between ZTTs and the ZTNA connectors. And this happens because we require redundancy. So we support redundancy where if the second ZTNA connector comes up, you have a second ZTT supporting that. And then this third ZTT comes up when the 9th ZTNA connector is spun up, and the 4th ZTT comes up when the 13th ZTNA connector is spun up. So in a specific region, you'll have about up to 4 ZTTs, but you can definitely have multiple regions with multiple ZTTs and multiple ZTNA connectors accessing private applications. And just to give you an idea, we can have up to 200 connectors in a tenant, and that's the support we give through our new licenses. And this is how the ZTT spin up backend and give that redundancy for private applications access. Now, moving forward, whenever we onboard a ZTNA connector, these are the different ways you can onboard a ZTNA connector. So there are 7 simple steps. The first step is configuring an application and connector IP address block. And as I was mentioning, the app Anycast architecture, which we follow, these application IP addresses are assigned to each application as a virtual IP. And that is basically used throughout the architecture to forward the traffic to the private applications through the ZTNA connector, which basically masks the real or the source IP, which basically adds another layer of security. And similarly, we have connector IP blocks, which are defined, and those help in giving those connector Anycast addresses to the connector groups and connectors for passing the traffic to the connectors. Similarly, once that is done, which is a prerequisite for starting the ZTNA connector configurations, you need to go to the Strata Cloud Manager UI and go to the ZTNA connector workflow, enable ZTNA connector. And after that, there are only 3 simple steps: configure connector groups, configure connectors within a connector group, and then onboard your applications as FQDN targets, wildcards, or IP subnets. And once you have done that and you have deployed the connector in the required environment, whether it is on-prem or cloud, it will automatically connect to backend, and you will see the connector control plane status and tunnel status as up. That indicates that the connector is up and running, and you will also start seeing the application status in the application target page as up. So once that happens, you should be able to connect using your mobile user Global Protect client, and you should be able to connect to your desired private applications sitting in your environment. Also, the final step is configuring security policy. So ZTNA connector adheres to the security policies configured in Prisma Access, and you can define the security policy according to your choice, and ZTNA connectors will adhere to that. So that's the final step. This was the high-level step, but before getting into the dashboard itself, I just wanted to show you how the dashboard looks. But before getting into that, I wanted to also give you an idea of the different constraints. So multiple applications or connector blocks cannot overlap amongst each other. So this is something we need to keep in mind. Application and connector blocks cannot overlap with each other. So you cannot have the same IP subnet block defined for the application block and the connector block. Application and connector blocks cannot overlap with the infrastructure subnet. So there is a place where you can see the Prisma Access infrastructure subnet, which Prisma Access uses internally, and that cannot overlap with the application and connector IP blocks. And similarly, we define a global protect private pool for the mobile users. The application and connector blocks cannot overlap with that. And if the customer is using Prisma Access browser with explicit proxy, we have to make sure that the application and connector blocks do not overlap with these RFC 6598 subnets used by EP, with if explicit proxy is being used with ZTNA connector. So these are the RFC 6598 addresses which cannot be used for application and connector blocks. These are some of the constraints you need to know before defining the application and connector block. And this is where you define the application and connector block. If you go to the workflows under Strata Cloud Manager, you will see the infrastructure settings. So this infrastructure setting is used for the Prisma Access internal infrastructure. And here are the application IP blocks and connector IP blocks which are defined here. So in this case, we are not using PAB Prisma Access browser with EP, and that is one of the reasons we are able to use this RFC 6598 address. But if we are using that, as mentioned before, we have to stick to other addresses which are not the three RFC 6598 addresses mentioned here. Now, moving forward, I also wanted to talk about the Anycast IP allocation. So this is how the ZTNA connector page looks. And if you see, you will see the overview page once you come to the connector workflow, where you will see how to enable ZTNA connector and the license information. Then you have the connector groups here. If you can see, I've already defined the connector groups. And if you see, the connector groups are assigned Anycast IPs from this connector IP block pool, which is something you need to define. Similarly, when you go to the other PA fabric, you can see that the connectors are also assigned Anycast IPs. So the connector has a 1/27 slice or a 32 IP address per connector from the connector pool. And per connector group, we have a connector group wide address from connector pool. And we also have a per tenant wide DNS wildcard address from connector pool, which basically is used for wildcard entries. Now, moving on to the application target page, I'm showing the FQDN targets here. If you can see, we have defined some FQDN targets, and that FQDN target gets an Anycast IP from the Anycast IP pool as shown here. So one per FQDN app entered specifically or learned from wildcard. So that is how this Anycast IP pool is defined. And this VIP or Anycast address is what we use to forward the traffic within the Prisma Access infrastructure to an application. Now, moving forward, just to quickly talk about the ZTNA connector journey, we have constantly improved the ZTNA connector product. If you see in the last 1 year. And today we support explicit proxy, Prisma Access based ZTNA connector, access to private applications. We have privileged remote access with ZTNA connector. As I mentioned, privileged remote access is the secure agentless access to non-web applications from unmanaged devices, which gives you access to private apps which use SSH, RDP, VNC. So that is also supported with ZTNA connector today. Similarly, we have user to app policy configurations using wildcard FQDNs, as I mentioned before, and we have significantly improved the scale. So per tenant, we support up to 10,000 applications, and per connector group, we support about 1,000 applications. So, and that scale, we are constantly improving that scale. And moving forward in the future, you will see more scale improvement and more throughput based improvements from a ZTNA connector standpoint. But when it comes to the latest features, we have some specific features which we have released recently. We support DNS SRV and SCCM support. So we can support Microsoft AD based domain controllers and authentication through them, which was not supported before. So we can support that now with the ZTNA Connector 6.0 release. We have OCI Marketplace support, which I will be showing shortly. And we also have some H.E.A.R.T alerts, which we have brought in to give the customers more access to more alerts from a ZTNA connector perspective for troubleshooting, etc. We have Bluebird Day Zero onboarding, which makes the ZTNA connector onboarding much easier. So we have an onboarding screen, which walks you through the Day Zero onboarding process for ZTNA connector to private application access. We also have introduced support in China. So that is something we are working towards from a ZTNA connector standpoint. And we have introduced FedRamp mod for ZTNA connector. So we support FedRamp mod environment with ZTNA connector. But for the future, we are also doing a lot of other enhancements. So as of today, ZTNA connector supports client-initiated traffic-based private apps. We are working on supporting server-initiated traffic flow as well. As of today, when we have ZTNA connector for server-initiated traffic, we have a product called Service Connection, which can be used for server-initiated traffic hand in hand with ZTNA connector. But moving forward, server-initiated traffic flow is something we will be supporting as well. We are also doing some scale improvements and throughput improvements per connector and per connector group, and as a whole for the tenant. As mentioned here, we are moving towards 20K applications per tenant and 4K applications per connector/connector group. So that is something you will see very soon. And we are also working on more connector form factors, which will be beneficial for brownfield and greenfield deployments, especially brownfield deployments, which have NGFW based firewalls. So we are working on more ZTNA connector form factors for such scenarios to make the customer's life easy. Now, moving forward, this is just for your understanding. This is a sizing guide. And as shown here with the latest 6.0 release, we are supporting 2 Gbps per connector, and that is a single client with single ZTNA connector setup for private applications. This throughput may vary according to the traffic. So right now, the 2 Gbps we are showing is for HTTP. And similarly, the number of connectors per tenant, as mentioned, is 200. We basically support 200 connectors in a tenant. As mentioned before, we are supporting 4 connectors per connector group, and the number of applications per connector is 1K, number of applications per tenant is 10K, and we do support 100,000 concurrent connections per connector as of today. Now, moving forward, let's talk about the new licensing. We'll be going over the new licensing changes that have happened with the 6.0 release for ZTNA connector. Originally, with the ZTNA connector, we used to support 3 add-on licenses: Essential, Advanced, and Premium. Right now, we are planning to do an end of sale for those 3 add-on licenses, and we are clubbing the ZTNA connector add-on license with an unlimited private app add-on license. So here we can see there are only 2 cases now. It is pretty simplified. If a Prisma Access customer does not have any unlimited private app add-on license, we will give them 10 connectors for free with 10,000 applications and 1,024 IP subnets. And if they need more than 10 connectors, they would have to buy the unlimited private app add-on license SKU, which gives them access to 200 connectors and 10,000 applications. We would still provide them access to the 10,000 applications and 1,024 IP subnets. And earlier we had restrictions based on the ZTNA connector add-on licenses for advanced features like wildcard entry dynamic privilege access support, etc. Those are all lifted now. So the licensing we have, having or not having a private app add-on license will only determine the number of connectors that they are allowed to have. Now, this is for the greenfield tenants. Now, let's talk about the brownfield tenants, which already had the various ZTNA connector add-on licenses. The plan to migrate is pretty straightforward. Customers who only had base licenses will move from supporting 4 connectors to 10 connectors automatically. And there were limitations on the number of apps that will be removed now. We will support 10,000 applications per tenant. Now for the first essential add-on license, we used to support 8 connectors, which will move to 10 connectors. So anyone with an essential add-on license can choose not to renew to the private app add-on license and still get 10 connectors. For the advanced add-on license, we used to support 40 connectors. They will migrate to the unlimited SKU, which is the 200 connectors. And the premium, which was the highest add-on license for ZTNA connector, had a support of 200 connectors, and it'll stay with 200 connectors. So anyone planning to renew their licenses will have to renew it with the unlimited private app add-on license to get more than 10 connectors. And this particular number, we need to understand that if you have an environment with service connections and ZTNA connector, the 200 connector value might vary. But if you have a setup only with ZTNA connectors, you will get a full 200 number of connectors per tenant. Now, moving forward, let's talk about the DNS SRV and SCCM support for ZTNA connector. So in Microsoft Active Directory deployments, if the domain controllers are deployed behind ZTNA connectors, currently users will not be able to authenticate remotely. So if you have a domain controller and you want to use Microsoft Active Directory for authentication for users, authorization for users, and you want the domain controller in your data center deployed behind a ZTNA connector, it was not working, or we were not supporting that currently. But with the DNS SRV solution, we support that by allowing the DNS queries of type SRV33. The Microsoft clients behind a mobile user can reach the domain controllers residing behind a ZTNA connector. This will allow Windows clients to join Microsoft administrative domain and use the Microsoft AD to authenticate, which will support things like DNS SRV, SCCM, and LDAP. So the prerequisites is upgrading your ZTNA connector to the latest 6.2.7 image. That will basically give you this particular feature. And we have some other requirements which will happen back in. Now, moving forward, for the purpose of this demo, we'll be using this topology. You can see that we have a mobile user connected to the MU gateway, which is the security processing node, and that connects to the ZTTs, which in turn connect to the ZTNA connector. There is IPsec, and you have eBGP with ECMP between ZTT and ZTNA connector, and then you have IBGP with ECMP between MU and ZTTs. And similarly, the traffic will go to a domain controller. So here we have one domain controller. So without further ado, let me get into the demo itself, right? So this is just for your understanding where we configure the DNS SRV and SCCM support for ZTNA connector. It is within the wildcard target page where we define a wildcard as the domain controller wildcard, and we enable certain parameters to allow DNS SRV and SCCM support. And when you inspect the traffic under networking and preview, you will be able to see that the domain controller IP is set to true. So once this is false now, but once you click on keep data center IP address, because it will be using the domain controller data center IP address, this will turn into true. So now without further ado, let me go into the demo itself. So here, if you see, we have the ZTNA connector page with the connectors. We have already defined an AD connector. We have a connector in the data center. We have already onboarded a connector here in Azure. This will be a 2-arm connector with the second arm having the DNS server as the domain controller. If we log into the connector, we can check that. This is the LAN interface, the second arm. Let me do one thing. I can maybe, yeah. This is the LAN interface, the second ham, which has the DNS server as 10.7.2.5, which you can see here. Um, Here we are logged into the domain controller. You can see that this is the IP of the domain controller as shown before, 10.7.25. I'm also showing this here. Then we go to the, so let's basically go over the configurations required. Once the connector is deployed, we need to create a wildcard target, which we are doing here. While creating the wildcard target, we will give it a wildcard target name, assign it a connector group. And over here for the wildcard, we'll give the domain as our wildcard. So we are going to currently we are using panw.local. That's the wildcard entry for the domain controller. And once we keep that, we will have this option to enable Microsoft AD and keep the data center IP address. If I do this, it will give me a warning saying this is only required for Microsoft domain services. I can go ahead and enable that, which will populate TCP and UDP ports automatically, which are required for DNS SRV for the clients joining the domain controller. This one is also required because Microsoft domain controllers expect the clients to talk to them with the specific IP address. When we enable this, as we discussed earlier, we will advertise the IP address of the FQDN into the Prisma access. We already have the same configured, so we can just confirm this. And one thing to note here is that the two configurations we discussed, the keep data center IP option, are kept backend. So it's a flag which is enabled. This is used domain controller IP set to true, right? So, and as I said, the wildcard is already defined here. And if you see, uh, we are basically going to inspect and we go to networks as shown in the screenshot before. So we go to features. And now moving forward, we are just going to here. We are basically looking into preview features. And you can see that once we enable DCIP, it is set to true. This is how we check that it is enabled. And now moving forward, I've logged into our domain controller itself. So I'm just going to go there. So yeah. So this is the version. If you see, we are on the latest 6.2.7 version, and that is needed to activate a DNS SRV. So now moving forward, I've logged into our domain controller itself. This is the domain controller Active Directory users and computers. And I also have this DNS server running on the domain controller itself. I have a client here, which is Windows client. This has currently not joined the any domain. We will go ahead and try to join the domain from the, yeah. So this is the Windows client. And from the Strata Cloud Manager dashboard, you can see that the wildcard is created, but the domain controller IP itself is not discovered here yet, which we checked before. So the domain controller IP is 10.7.2.5, right? And that you cannot see as discovered under FQDN targets because the Windows client has not joined the domain controller yet. So from the client machine, I'm just going to change the work group to our domain. Before that, we are also starting, like I've just started a packet capture via Wireshark on the client. We will just have to go within with the change domain name. And from the domain, we join panw.local. So I'm just clicking rename the PC. And I'm going to change the domain here. I'm just going to type in domain panw.local. I've already connected to the GP client, so this should be good. I've started the packet capture here, and from the client machine, I'm going to join panw.local. And I've clicked OK. So once we start trying to connect to the domain controller, we should see that the domain controller was discovered, and we have that discovered through the wildcard. And we can try seeing that here. So you can see that the domain controller has joined here. You can see it identified as an FQDN target. So now we are using our username and password to join the domain. Yeah, so now you can also see that the packet capture is flowing, and you can see the Active Directory traffic coming in. And if you go to computers, you will see the client has already joined the Active Directory. And you can see that here as well with the host IP. You can see it under the DNS manager as well, which shows that the client is working behind the ZTNA connector, joining the domain controller. So you just need a restart. And once you do a reboot, it will ideally ask you for the username and password again, and you should be able to go in. So if you see the packet captures, you can see that we have, a lot of LDAP packets coming in. You can see that here. I'm just going to search for DNS, and you can see here, yeah, LDAP, SRV LDAP, so which confirms that the host has joined the domain controller. So that's for the demo for the Microsoft SRV and SCCM support. Now let me quickly go into the next slide. Uh, as we are short on time, I just wanted to talk about the OCI based support we have. So we support deploying ZTNA connectors on OCI platform today with the latest 6.2.7 B8 VM image. The only catch is that we support one arm connector, but if you go to the OCI marketplace, you should be able to find that there, and we can also deploy with the OCI image itself. So we do support the one arm, one NIC connector on OCI. So I do have a demo for it, but we can skip that. It just shows how we deploy a connector on OCI. And the next one is FedRamp mod version. So we support ZTNA connector in FedRamp mod. The prerequisites are having a 6.2.5 plus ZTNA connector image. So there is a specific image for FedRamp mod, which can be used. For Greenfield Prisma Access tenant onboarding, use essential, advanced or premium ZTNA add-on licenses to the base Prisma Access license. SD-WAN tenant auto-created by ZTNA microservices and mapped to the same TSG as the Prisma Access tenant. And you can check the connector application limits under Strata Cloud Manager Workflows ZTNA connector overview. And the FedRamp mod basically has all the features which are there for a commercial environment. So ZTNA connector will support all the features which are there for a commercial environment. But the only catch is that ZTNA connector in FedMod, even though it's available in Prisma Access 6.0.0 release, some of the latest ZTNA connector features like DNS SRV and connector on OCI are not available as of today, but we will be working on making it available for the FedRamp mod as well. But all the other features will be accessible through the ZTNA connector FedRamp mod version. Now, moving forward, just wanted to quickly talk about the alerts here. So these H.E.A.R.T alerts is monitoring the internal ZTNA connector behavior. We want to consolidate all these alerts so that the customers can use that. So for the ZTNA connector side, in phase one, we are adding these 4 alerts. The goal is to bring it to prod. The 4 alerts shown here are the ZTNA connector SD-WAN controller service down alert, which basically talks about the controller backend showing if the control plane was down. This can be used to monitor that. Similarly, if the customer configured any connector with overlapping subnets, like 2 ARM connectors with overlapping subnets, then that will also be caught. We have all these different alerts, overlap subnet alerts, tenant creation failure alerts, service down alerts, etc. The first 3 alerts are low-key log alerts, and the final one is basically the interface change or subnet change alerts. So these are quick things we have introduced. We have started to introduce these AI ops based alerts for ZTNA connector.